Hello, Cherry,
Yes, sir.
Geet.
Yes, sir.
Fine. Today we'll discuss about the applications of equation of motion and motional gravity. Okay. Applications of equation of motion and motional gravity. Okay. Fine. Yesterday, in the last class, we discussed about the equation of motion and then motion under gravity. Motion under gravity. In that, let us consider a particle starts from A, moves to B, traveled a distance, suppose let us consider S, traveled a distance S in a time of n seconds, okay, fine. Now, let us consider a point, suppose C. From A to C, it takes a time of n minus 1 second. That is, this is the last second. Okay, na? In this last second, I want to find what is the distance. Okay, fine. So here we are going to find distance traveled in the last second or nth second. Distance traveled in nth second. Okay, na? Fine.
Okay, sir.
Okay, sir.
This we are going to find. Okay. So in n minus 1 seconds, it traveled a distance. Let us consider S1. So I can say that S minus S1 is equal to distance traveled in the last second. Let us consider it as N, Sn. Let us consider it as Sn. Okay. So let us consider it as equation 1. Since it starts from rest or it is having an initial velocity. So by using the equation of motion, can I say that it is from S equal to ut plus half at square. Here it takes a time n seconds. So S equal to un plus half an square. Can I say? Okay, na?
Yes, sir.
Is it fine?
Yes, sir.
Similarly, we are having that S1. It takes a time of n minus 1 second. S1 equal to u into n minus 1 plus half a n minus 1 whole square. Okay, na? Fine.
Okay, sir.
Okay. Now, substitute the value of S and S1 in the first equation. In the equation 1. That is Sn equal to S minus S1 un plus half an square minus of u times n minus 1 plus half a times n minus 1 whole square. Okay, na? Fine. Expand this minus sign. That is un plus an square by 2 minus un plus u. Okay, na? Fine. Is it okay?
Okay, sir.
Okay, sir.
Okay, fine. Un cancel and an square will get cancelled. That is u minus a by 2 times minus 2n plus 1. Take minus sign common, which will get u plus a by 2 into 2n minus 1. That is the distance traveled in the nth second. Sn is the
Yes.
distance traveled in the nth second, right?
Yes, sir.
Yes, sir.
Distance traveled in nth second. Okay. Remember this formula. Now here it is the point that already we are having s equal to ut plus half a t square. Right? Fine.
Yes.
Fine.
Yes, sir.
Okay. Suppose if the particle, okay, travels a distance s, okay, in 0 to 4 seconds. In a time interval of 4 seconds, particle travels a distance or displacement. Then I will apply this formula. That is for a time interval, fixed time interval, then I will apply this formula. Suppose if a particle travels a distance, okay, 10 meters, it takes a time of, okay, 7 seconds. It takes a time of 7 seconds. Now I want to find what is the distance traveled. What is the distance traveled at 3rd second or 4th second or 6th second? Then we'll use the formula Sn equal to u plus a by 2 into 2n minus 1. Okay, na? Fine, na?
Okay, sir.
Is it okay?
Okay, sir.
Okay, fine. Na? Next, you can see u plus a by 2 into 2n minus 1. So
Yes.
distance travel in the nth second, it is u plus a by 2 into 2n minus 1. U plus a by 2 into 2n minus 1. Okay. Fine. Okay. This page completed, huh?
No, sir. One.
Write down.
Completed, sir.
Completed, huh?
Yes, sir. Completed, sir.
Completed, huh?
Yes, sir.
Next. Okay. Second application. Second application. Suppose, let us consider we are having a ground. Okay. We are having the ground. This is my ground. Okay. We are having a building of height h. Of height h. Let us consider we are having a particle or object. Okay. Here it is. It is projected vertical upwards, reaches to a height and then comes to ground. Right?
Yes,
Fine.
sir.
Okay, sir.
It reaches to a height and then comes to ground. Let us consider, okay, I am considering this point as A, this point as B, okay. Here it is C, and this point is D. Now, in this application, I am going to find relation between H, U, and T. H, U, and T. Okay. Fine.
Yes, sir.
Fine, sir.
Okay, fine. Now, can see firstly, what I can say, since by using the relation S equal to ut plus half at square, S means
Yes, sir.
S means displacement.
Yes, sir.
Yes, sir.
Okay. Here from displacement from A to D.
Yes,
Now,
sir.
observe here how much it is raised to height A to B. That much it is falls down.
Yes, sir.
That means from A to C, displacement, can I say 0?
Yes, sir.
Okay, na? Is it fine?
Okay, sir.
Okay, fine. Okay, fine. So, up to C it is displacement is 0. From C to D, I need to find displacement.
Yes, sir.
Okay. From bottom to the top, it is height of the building now.
Yes, sir.
Yes, sir.
So C to D means, can I write minus H?
Yes.
Okay. Because displacement can be negative.
Yes.
Can be negative. Okay. ut. Since it is projected upwards, a equal to minus g. Okay, na?
Yes, sir. Okay, sir.
So multiply by minus sign on both sides. That is h equal to
Is equals to
minus ut plus half gt square. Okay,
Okay, sir.
fine.
fine, sir.
Okay, this is the formula when we need to use means body is projected. Body or particle is projected
What?
from height of a building or tower. From height of a building or tower of height h. Okay, na?
Okay,
Okay,
sir.
na? Fine, na?
Fine, sir.
Okay, sir.
Okay. This one, second application.
Sir, 1 minute. I'll wait.
Okay, na? Is it fine?
Fine, sir.
1 minute, sir. I'll wait.
Ah, writing, ah? Okay,
Yes,
right.
sir.
Okay, right.
Done, sir.
Completed, sir.
Okay, na? Completed?
Sir, completed.
Next application, write down. Suppose, let us consider we are having an block of wood. Okay. Third application. Okay. Third application it is, we are having a block of wood. Like this block of wood is there. Okay. Fine.
Yes,
And
sir.
we are having a bullet. Bullet is having a mass m and it is moving with a velocity u. Okay. Now, whenever the bullet touches this wood, then bullet loses 1 by nth of its velocity. Is lost. Okay. While
Okay.
penetrating through a plank. Then we need to find the minimum number of planks. To stop the bullet. Planks means, okay, we'll have like this.
Sir, what is n here?
What is?
N here. 1 by nth of velocity loss.
That only n we need to find. That only you need to find. 1 by nth velocity is lost. Okay. That n will be belongs to set of natural numbers or where n is greater than 1. where n will be greater than 1.
Okay, sir.
Okay. Now see, I'm shading the region. Observe here. This is one plank. Like that, we'll have number of planks.
Yes, sir.
How many? We don't know. How many number of planks we are having? We don't know. Among these, I need to find what is the minimum number of planks. Okay, na? Among these, we need to find minimum number of planks.
Okay, sir. Okay, sir.
Fine. Let us consider, I am considering that, let number of planks required, don't write. Whenever you are writing, I will tell in the words. One, to stop
Okay,
the
sir.
bullet. Let us consider it as M. Okay, na? Fine.
Okay, sir.
Instead of M, you can consider any other letter, P also, no issues. So, this bullet, I am considering that after traveling a distance here at this point, 1 by nth velocity is lost. So, remaining will be U minus U by N. Can I say?
Yes, sir.
There. U minus U by N. Okay, fine. Whenever it reaches, suppose here it will be. Okay. Initially, from bullet to this point, I am considering. Suppose this is A and this point as O. O to A. By using the principle V square minus U square equal to 2AS. Okay.
Okay, sir.
Up to here, A I'll consider here. So, at A it is U minus U by N whole square minus U square. Distance travel is X. Okay, na?
Okay, sir.
Okay, sir.
Fine. This is first equation. అంటే ఈ పాయింట్ ఏ దగ్గర మనకి ఇప్పుడు వెలాసిటీ ఎంత ఇది కదా u minus u by n. At this point it is u minus u by n. Suppose let us consider at this point, point C, bullet comes to rest. Bullet comes to rest. So I can say that velocity will be 0. Avuna? Is it right?
Okay.
Bullet comes to rest. Is it fine?
Yes, sir.
Yes, sir.
Okay. Now, bullet comes to rest after traveling m number of planks. That is, initially it is 0. From O to C, I am considering. So, 0 square minus U square equal to 2A after traveling a distance mx. Okay, na?
Okay, sir.
Fine.
Okay, sir.
So, అంటే ఇదేంటి మైనస్ U square equal to 2A mx. Consider it as second equation. Consider it as second equation. From equation 1, we are having that u minus u by n whole square minus u square equal to 2ax. Avuna? See.
Not okay, sir.
Okay, that means here I'll take u common. Ante u square into 1 minus 1 by n whole square minus u square. So, u square times 1 minus 1 by n whole square minus 1 equal to 2x. Consider it as equation 3.
Okay.
Equation 2, we are having that minus u square equal to 2amx. Okay. What I should find? What I should find?
N.
M, number of planks. So what I will do it is equation 4 by equation 3. That is 2amx by 2ax equal to minus u square by u square times. I'll expand this one. 1 plus 1 by n square minus 2 by n minus 1. Okay. Upon calculation, we'll get m equal to minus 1 by n square minus 2 by n. Okay, na?
Okay, sir.
Multiply and divide by minus sign. So this I can write 2 by n minus 1 by n square. Can I write?
Yes, sir.
Yes, sir.
Ante m equal to 1 by 2 by n minus 1 by n square. Take LCM, that is n square. It is 2n minus 1. So number of planks required will be n square by 2n minus 1.
Yes, sir.
Is it fine?
Yes, sir. Fine.
Yes, sir.
Okay, na? Okay, 1 minute. Write down. 1 minute. Write down the statement. If a bullet, if a bullet loses loses 1 by nth. Write down like this. 1 by nth. 1 by nth of its total velocity while passing through a plank. While passing through a plank. Okay. While passing through a plank. Then minimum number of bullets that are required to stop the bullet is bullet is. Okay, na? Fine, na?
Okay, sir.
Okay, sir.
Okay, sir.
Write on this one. Write on the page.
Completed, sir.
Yes, sir. Completed.
Done, sir.
Complete.
Completed,
Yes, sir. Completed.
Completed, sir. Completed, sir.
Okay.
Done, sir.
Fine. Right.
Sir, over.
Over.
Yes, sir. Completed.
Okay. Fine.
Over, sir.
Very completed,
Yes, sir. Completed.
Completed. Next, I think next application, it is number 4, I think. Once you see,
Yes, sir. Number
Yes,
4.
sir.
number 4, it is the velocity of a bullet, becomes 1 by nth of the initial velocity while penetrating a plank. While penetrating a plank, the minimum number of planks required to stop the bullet is. required to stop the bullet is, okay, fine now. That
Okay,
means,
sir.
suppose this is the wood. In this, we are having the planks like this, same as like before. Okay, X. Okay, fine. Here
Okay,
we are
sir.
having a bullet. Moves with an velocity u. Initial velocity as u. Bullet is moving with velocity as u. So after penetrating, here it is, velocity will be 1 by nth of initial velocity, and u by n. Right?
Yes, sir.
Fine. That
Fine.
means u minus u by n, velocity is lost. Velocity is lost. Okay, na? Is it fine?
Okay, sir.
Once you see the difference between this application and previous application. Once you see the difference between this application and previous application. That is, here in the previous application, u by n is lost. Right?
Yes, sir.
Okay. Here it is, u minus u by n is lost. This one it is, u minus u by n is lost. Okay. So bullet travel a distance x. So by using the principle v square minus u square equal to as, so u by n whole square minus u square equal to 2ax. Can I write? Okay, na?
Okay, sir.
After traveling m number of planks, final velocity will be 0. Let us consider it as equation 2. From equation 1, we can say that u square take common, 1 by n square minus 1 equal to 2ax, called as equation 3. Equation 2 by equation 3, that is minus u square by u square times 1 by n square minus 1 equal to 2a mx by 2ax. Okay, na?
Okay, sir.
M equal to minus 1 by n square minus 1. This I can write as 1 by 1 minus n square. Okay, na? So it is
Okay.
n square by n square minus 1.
Yes, sir.
See the difference. Okay. Since it is velocity is lost. Okay. Whenever it is penetrating, with what velocity it is penetrating into planks, depends on that we'll have number of planks. Ona? See? Okay, na? Fine.
Yes, sir.
Okay, sir.
Okay. Then it, okay, write down.
Completed, sir.
Completed, huh?
Yes, sir.
Next.
Completed, sir.
Completed, huh? Cherry, completed, huh?
Yes, sir. Completed.
Okay, fine. Next. Fifth application. If a object moves with uniform acceleration, a body crosses a point X with a velocity u, and another point y with a velocity v, they will cross the midpoint of x and y with a velocity v1. Find v1. Okay, na?
Okay, sir.
Is it okay?
Okay, sir.
Okay, fine. We are having a small diagram. That is, let us consider this is B. Okay? This is X and it is Y. Here it is U and this is V. Okay? At midpoint, suppose C, it is having a velocity V1. Midpoint means, can I say this distance is S and this distance is also S? Can I say?
Yes.
Okay, na? Fine.
Okay, sir.
Okay. We need to find V1 value. So firstly, I am considering from A to C. That means V1 square minus U square equal to 2as. Can I say? Similarly, from C to B, that means V square minus V1 square equal to 2as. Okay, na? Is it fine?
Okay, sir.
Okay, fine. See, from the first two equations, right hand side is same. Right hand side, it is same na.
Yes, sir.
So I can equate. That means V1 square minus U square equal to V square minus V1 square. Okay. Fine. Na?
Fine, sir.
That means 2V1 square equal to V square plus U square. So V1 equal to under root V square plus U square by 2.
Okay, sir.
Okay, na?
Okay, sir.
Hmm. Fine. Na?
Fine,
Yes,
sir.
sir.
Okay, fine. Na? Write down. Completed.
Yes, sir.
Okay.
Completed.
Okay, fine. Na?
Completed, sir.
Completed. Huh?
Yes, sir.
Fine. Up to here it is. These are the applications in the equations of motion. Okay.
Okay,
Up
sir.
to, up to here it is. These are the applications in the equation of motion. Now, applications of motion under gravity. Applications of all these you need to remember, because again we'll apply in our problems or numericals.
Okay,
Okay,
sir.
na?
Okay,
Fine,
sir.
na? Okay, fine. In this motion under gravity, okay, we have studied about vertically upwards, vertically downwards, and then free fall, right?
Yes, sir.
First, I am considering vertically downwards. For a freely falling body, okay, freely falling body, what is the initial velocity?
0.
Oh, very good, 0. Then the ratio of distances traveled, the ratio of distances traveled, distances traveled in regular intervals of time, regular intervals of time. Regular intervals of time means first second, second, third second, fourth second, etc. Right? Fine.
Yes, sir.
Yes,
So
sir.
interval between these two, time interval is 1 second.
Yes, sir.
Between
Yes, sir.
successive times, it is 1 second. Right?
Yes,
Yes,
sir.
sir.
Fine. So let us consider in the time interval, okay, that is T2 minus T1. First second as T1, T1 equal to first second, T2 equal to second, T3 equal to third second, T4 equal to fourth second. In this time interval, distance traveled is S1, S2, S3. Okay? Fine.
Yes, sir.
Okay. That means I need to find S1 is to S2 is to S3. S1 is to S2 is to S3. This we need to find.
Okay, sir.
Okay, sir.
Okay. Suppose this is the ground mass. For a freely falling body, that means like this. Okay? Fine. Suppose this point is A, B, C, D, and it is E. It takes a time, first second, this is. Okay? And B to C, okay, another first second. A to C means 2 seconds. Right? A to C means 2 seconds. Atla. Similarly, C to D.
1 second.
Okay? So A to D it
Okay.
is third second.
Yes.
Yes, sir.
A to B I am considering as S1. B to C I am considering as S2. C to D as S3. Since it is falling freely, initial velocity is 0. So by using the principle S equal to ut plus half at square,
Yes, sir.
that means S1 equal to initial velocity is 0, right?
Yes, sir.
Yes, sir.
Ante S1 equal to A by 2 and right, sir? Can I say?
Yes,
Yes,
sir.
sir.
Similarly, okay, from here to here, A to C, it is 2 seconds. Total distance it is S1 plus S2.
Hmm.
Right?
Yes,
Yes,
sir.
sir.
Okay. Otherwise, we need to find velocity at B and then we need to write. Here it is, we will have initial velocity U1. Instead
Yes.
of that, I am taking from A to C. At A, initial velocity is 0 now.
Yes, sir.
A to C takes a time 2 seconds. Distance travel it is S1 plus S2.
Yes.
So 0 into 2 plus half multiplied by A multiplied by 2 square. So
Yes.
S1 means we got as A by 2
Yep.
plus S2.
Yes, sir.
It is 4A by 2. So S2 equal to 3A by 2.
Yes, sir.
Okay, na? To
Okay,
find
sir.
S3. To find S3. What I will do, from A to D I will take. A to D I will take. So A to D. Total time taken it is T3,
Yes.
3 seconds. Okay,
Yes,
na?
sir.
Okay, sir.
Total distance traveled A to D. See,
9A by 2.
S1 plus S2 plus S3.
S3.
That means I can write S1 plus S2 plus S3 is equal to 0 into 3 plus half times A multiplied by 3 square. S1 plus S2 means nothing but 4A by 2. Na?
4A.
Yes, sir.
4A by 2 plus S3 equal to 9A by 2.
Yes, sir.
Yes, sir.
That means nothing but 5A by 2.
Yes, sir.
If you observe carefully, we are getting in the odd multiple S1 is to S2 is to S3 equal to A by 2 is to 3A by 2 is to 5A by 2.
Yes,
Okay, na?
sir.
Yes, sir.
In each term, okay, I'll multiply it by 2 by A. Two by A, which will get as 1 is to 3 is to 5.
Yes, sir.
So whenever a body is falling freely or whenever body is moving with a constant acceleration in regular intervals of time, highlight this one, in regular intervals of time, ratio of distance traveled, it is 1 is to 3 is to, in regular intervals of time, it is 1 is to 3 is to 5 and so on. Okay, na?
Okay, sir.
Write down. This page completed, huh?
Yes, sir.
Yes, sir.
Completed, sir.
Completed, huh?
Yes, sir.
Okay, fine.
Complete.
Okay. Why completed, huh? Cherry?
Yes, sir. Complete.
Okay, fine. Next, another application. I think motion and gravity, second application, huh?
Yes, sir.
Yes, sir.
Once you see,
Yes, sir. Motion under gravity, second application.
second application, it is, suppose, let us consider a freely falling body. A freely falling body passes through 2 points. Passes through 2 points, A and B, at distances h1 and h2 from the start. From the start. Then the time taken by it to move from A to B is, okay, A to B is, suppose this is the ground mass. Let us consider particle is falling freely. Let us consider this point as P. Okay. From the start, see, from the start, point A is at a distance h1. Okay. And point B is at a distance h2. Okay, na? Fine.
Okay, sir. Okay, sir.
Okay. Now
Yes.
we need to find this time interval. Let us consider it as T. Particle takes a time T to move from A to B. Okay, na? Fine. Na?
Okay, sir.
For this, what I am doing that, from P to B, let us consider it takes a time T2, and P to A, it takes a time T1. Okay, na? So can I say that T equal to T2 minus T1? Can I say?
Sir.
Okay, fine. So, since it is a freely falling, since body is freely falling, what is the initial velocity?
0.
Okay, u equal to 0. That means by using the principle s equal to ut plus half at square,
Yes, sir.
first P to A, what is the distance traveled?
H1.
Right? So,
Yes, sir.
since it is falling down, what is the value of acceleration?
Positive.
Positive.
Positive what?
G plus G.
A equal to plus G. Okay, na?
Okay, sir.
Fine, na?
Fine, sir.
Yes.
Okay. That means T1 equal to under root 2h1 by G. Similarly, P to B, that is h2 equal to half G T2 square.
Yes, sir.
Yes.
T2 means under root 2h2 by g.
Yes, sir.
Yes, sir.
So time taken t equal to t2 minus t1. That is under root 2h2 by g minus under root 2h1 by g,
Yes, sir.
Yes, sir.
which I can write under root 2 by g, take common, root h2 minus root h1. Okay, na?
Yes.
Yes, sir.
Yes, sir.
Okay, fine. From the diagram, among h1 and h2, which value is greater?
H2.
H2, sir.
Yeah. So here time it is positive only, na?
Mm.
Okay.
Okay,
Time
sir.
will never be
Okay.
negative.
Yes.
Yes.
Okay, na? Right on. Second application.
Sir, G value put చేస్తే వస్తుందా సార్?
G value?
G value 9.8 అని పెట్టి చేస్తే అది కూడా చేయొచ్చా సార్?
You don't know h1 and h2, na?
Okay, sir.
You don't know h1 and t1. Only one value we know now.
Okay,
If I
sir.
know any other value, then we can put. Okay, na? Completed?
No, sir. 1 minute.
Completed.
No. Both of you completed. Huh?
Yes, sir. Completed.
Complete.
Okay, fine. Next, third application. A stone is dropped. A stone is dropped into a well of depth h. Of depth h. Then the sound of splash is heard after a time t. After a time t is. Okay. Suppose, let us consider we are having a well like this. Okay. Fine. Huh?
Okay, sir.
This is having a depth h. A stone is dropped into a well. Suppose here stone is dropped. Okay, na? Like this. Whenever it is dropped, okay, then what will happen? Sound will come. Right? Huh?
Yes, sir.
So we need to find total time. Whenever stone is dropped into a depth h.
Yes, sir.
So T1 equal to, I can write as 2h by g.
Yes, sir.
That is, T1 is the time taken by stone to reach water. Okay, na?
Okay, sir.
Okay. T2. Whenever stone is dropped at the bottom of the well, then sound will be produced. So, speed of a sound equal to distance traveled by time. Distance travel is h. Time taken is t2. Okay. Okay, na?
Okay, sir.
So, total time equal to under root 2h by g plus h by speed of sound. Speed of sound. Okay.
Okay, sir.
Write down. Okay, na? Fine.
Yes, sir.
Okay. Completed?
Yes, sir.
Yes, sir. Completed.
Fine. Let's stop here. Some more applications are there. Okay, we'll discuss tomorrow.
Okay,
This one
sir.
and graphs.
Okay, sir.
Okay, sir.
Okay. This one and graphs will be there. After that, that will complete the chapter.